Hello YouTube, welcome back to the Vacuum Breather channel and my devlog on the Montreal project. This time I'm going to show you what advances I made in terms of UI, but that will just be the first part. I have something a little bit bigger to show you, but just to give you an update on where the game is actually at. Let me jump right into it. As I sneak peeked already last time, I did a little bit of UI work so far with UniUI, so no UI elements yet. I'm not sure whether I'm going to use those UI elements for the actual in-game UI anyway. Depends on how much progress is being made there. But as you can see, I can now switch the turn and always have the current player here, and the advance is now that also every unit can only move once per turn. This little green dot here shows whether it can still move. All, of course, nice programmer art. So far, I may do some advances in the actual graphics department in the near future, but for now, still placeholder graphics are fine. And if I switch to turn to the second player, I can now actually move its units. Obviously, they are not blocking each other yet, and what I also don't like yet is that when I switch to turn, all of these things gets reset, and even the units that can't move because they're the enemy units, they still have that green dot. But that's stuff for the future. That's how these advances are currently. Let me show you the structure here. I have a little gameplay UI here. That is part of a prefab, obviously. Well, it is an entire prefab. And as you can see, I've also made some advances here. I imported the rainbow folders and rainbow hierarchy things. So I have some nice little icons here just to help me out figure stuff out. Here my grid is now the tile maps and the grid itself, the camera. And in here we also have the appropriate icons. So this is basically what it looks like. Nice little canvas here, canvas group for the pop-up. And let me actually get the inspector over here so you see what's going on. So here we have a canvas group that I can fade in and out. We have background for the button, the text, and all that good stuff. So yeah, before I go into that a little bit more, next time when I have more advances, let me actually show you what I did as a major refactoring this time. And for that, I'm going to quickly jump into the code and show you what I did here. Now, let me jump right out of the game installer. We don't need that yet. Or we're going to need it, but let me explain you first what it actually is all about. Or what problems I actually tried to solve with this refactoring. Now, in terms of dependencies, all of these things, of course, have dependencies on other components. Like we need sometimes when we go into the interaction layer, for example, this thing, as you can see, it needs the unit layer, it needs the game of information, which I'm going to rename probably in the future. That is a stupid name. And it needs the time map and all that stuff. Now, if it is on the same game object, that is easy. I'm just calling this, and that's just a fancy way of saying, okay, if it doesn't exist yet, go get it from the get component. I'm doing that with an extra method and not simply in await because I sometimes have code running in edit time, so I need to be able to get it even if awake isn't called. But this is basically just a fancy way of me doing get component. I do it with a fancy thing here because I initially had the idea, okay, I can also have a factory method in here in case it is not a simple get component, but it's, for example, get camera main or something like that. I can specify an action here to initialize that. Whether that's going to stay here is questionable because I actually plan on getting rid of all the in-editor code and put that somewhere else. Probably inside a custom inspector where it actually belongs. But for now, that's just a fancy way of doing that. The bottom line is if I just have a get component and I can get it on my own game object, that's fine. I can do that in awake. That's no big deal. As you can see here in awake, I call the same thing. I just get the tile map and done. Perfect. However, There are some things where I don't know why they are. First of all, I need to get the message broker here, these receive and the appropriate publish method, or the corresponding publish method. Internally, they go into the message broker. Well, where do I get the message broker? As you can see, inject here, I've changed something here, but before that was either hard-coded because I needed that kind of thing. The logger is another thing. Logger, I initially hard-coded in here, but I don't really like doing that because that interferes with my unit test and it's actually logging to the log. The unit test is spamming my log and stuff like that. And the message broker actually had the problem. If I called the message broker inside a unit test and I had a certain scene open, well, since I had code in here that was running at edit time, it needed to subscribe to the message broker in edit time. So I had a nice little attribute over here over some of my components, execute always, which previously was the now deprecated execute in edit mode. And that would call enable. And in enable, I have the entire subscriptions. As you can see here, I'm subscribing to all the events and listening to them. And that was a problem because now my unit tests were writing to the same message broker and my edit time stuff in this open scene was actually reacting to it. I actually think that's a big problem with Unity. That the unit tests that run in edit mode can actually interfere with the actual open scene if there's any in edit mode code running in there, but whatever. Not just a problem with Unity, it's also a problem of my design. So I needed to get a different message broker going in my units, but how do I get that in here? So I wrote some stuff and my unit tests and wrote, okay, yeah, unit tests don't have to have production ready code, so I can do hacky stuff in there, you know? So I went in reflection and I said, okay, inject this new message broker in here, and it would go through all the fields in that class and look for one that has the type message broker and just overwrite that with the unit test message broker. But I didn't necessarily want to do that either because, okay, yeah, I'm injecting stuff now on unit tests and I need to do reflection magic for that. That's not really nice. And I also need to get replacements for all the, of course, dependent things in here. And I showed you I had that nice little reference dependency reference thing where I went and said, okay, if I have an interface reference here, I'm going to put a custom serializable class in here, then I can assign in the inspector and all that. So I can actually have a dependency on a interface here because that's kind of the baseline if I want to replace that with a mock in the unit tests. But then again, I have a serialized field somewhere in here. And you can see that I got rid of that by this no longer being a serialized field. I just put that in here, and then I needed to get that by reflection again in the unit test because I don't like making my serialized fields public because they shouldn't be public. They should just be visible to this to the inspector. And all of that was kind of working fine, but I had problems in the editor as well. Let me show you. Going back real quick to the Unity editor, and if I open this thing here, let's say I go into the interaction layer. Okay, now I have a lot of dependencies in here, and I need, well, I don't have them in here anymore, but let's say any of these fields would be any components that I need to drag in here. And I need to drag that in there, and some of them I can already set in my prefab because I have them here already. They're part of the prefab, but there's other stuff I can't have part of the prefab. For example, the camera. If I need the camera, that is of course not part of the prefab. That's somewhere in the scene. So I need to drag some dependencies in here in prefab mode. In some, I need to do that in the actual scene. And when I add stuff and dependencies or add new systems that will be dependencies, I kind of lose an overview of what I have to assign in the prefab and what I need to assign in the scene. Obviously, I get errors and I figure that out, but it's just a whole bunch of drag and drop, and I forgot something here again, and I forgot something there, and now I broke it in that other scene. That's just getting annoying. So I decided, okay, if I'm already writing reflection code to do dependency injection in my unit tests, why not go all the way? And that's what I did. I got the package Zenject, or in this case, Extenject. There were apparently a little bit of a license discussion from somebody leaving his company, but whatever. That's not my problem. Bottom line is it still exists on the Essence asset store under the name Extenject. It's just a fork of the original Zenject, which is a dependency injection framework for Unity. Probably a lot of you already know that thing, but for those of you who don't, let me just quickly go through that. Dependency injection, I'm not going to explain what that is. You can do that on your own time. There's more than enough resources out there, but for those of you who are coming from business applications, you're probably aware of dependency injection frameworks like MEF, or actually one that is called Unity, which has nothing to do with this Unity. But you think, okay, that's fine. That introduces dependency injection, that creates all my classes that I need, but how the hell do I do that in Unity? First of all, mono behaviors cannot be created by calling new, and second of all, I already have stuff in my scene that shouldn't be created, but I still need to inject into it. It already exists. So how do I do that? Well, there's basically a couple of ways that Zenject does that. First of all, you have certain contexts. You don't have just one dependency injection root, which is usually the app class in stuff like WPF or whatever framework you're using. No, in this case, you have several. You have one on the actual project layer, which is done by having this little thing here in the project resources. That is basically setting up everything for the entire project. And as you can see, I have a game installer here, and the contexts basically reference installers, and the installers actually create the bindings. I'm going to go look into the game installer later. And then you have something similar for the entire scene. So each scene has its own context, which makes sense in terms of a game. If you switch out scenes, you probably have stuff that just needs to be in the container of that scene. And this is actually not something new. Even business application dependency injection frameworks have something of a scoped container concept. Like you can have a different subcontainer for a certain plugin or for a certain module or feature of your application. So that is pretty familiar. This has just been adjusted to, all the concepts of modules or individual features that we have in Unity. Obviously, the first modular concept in Unity is the scenes. So we have one concept for each scene, and you can see, okay, there's actually no installers installed here. So what's the scene context actually doing? Well, as I said before, we don't create bindings for new instances all the time. In scenes, you might actually want to just introduce the stuff that you already have in the scene. Like I already have stuff here. This stuff doesn't need to be created. I just need to have the dependency injected into it. So how do I do that? Well, if I go into the prefab here, then you can see there is a Zenject binding script in here, and that is actually setting up the binding. That is saying, okay, I need this component. I can just drag that in here. I publish the grid component here, or the grid map information component, actually, this one. And I want to inject that everywhere, either as myself, so under this class name, or in any of the interfaces that I implement. So I have that in here. I have that on here. As you can see here on the Zenject binding, I do the interaction layer. I do the unit layer in here and the terrain layer in here. And if I go out, you can see that the main camera is doing exactly the same. I'm going for the camera component. This way, just as itself, because the camera is not implementing any interfaces, at least not any that I know of. So I just need the camera. I'm going to import that as a camera. I can also give it an identifier. Once I have more cameras, that might make sense. So I can call this the main camera. For now, I only have one, so I don't need that. Doing the same for the event system, and in here in my UI, I do the same for all the stuff that my script here needs. The gameplay UI script, as you can see, there's no fields on there, but it needs some stuff. And I have also a game object context on this and on the grid. Why do I do that? Because they are prefabs. If I go into my gameplay prefabs folder, as you can see, the gameplay UI and the gameplay systems and the grid, which is this thing, are their own prefabs. So gameplay UI has its own gameplay context because the next modular concept below scenes are prefabs. So every prefab has its own context. So all these components that I install under the grid with the Zenject binding end up not actually in the scene context, but in the grid context. Same with the gameplay UI. Let me see, where do I actually publish something? For example, this button is publishing itself. Obviously, the pop-up needs to be published since I need to fade that in or out. So I need that. I also have it in identifier because it's probably not going to be the only canvas group around, at least potentially in the future. So I publish all of these. And how does that actually work in the code? Well, let's jump right back into that. There we go. And let's actually look at, for example, the interaction layer. You have different ways of doing an injection. You have a constructor injection. That's the classic business application way. But even those dependency injection frameworks support either property injection or method injection or other stuff. In this case, I kind of want a constructor, but obviously a mono behavior. This is just my custom base class. As I mentioned in previous videos, this is just a mono behavior, just me adding some stuff. Obviously, those can't have a constructor, so I do my own. I even set up my cleanup here so it ends up in the constructor region. I just call it create, give it the inject thing, which in this case I actually need. For constructors, it's optional unless you have more than one constructor. Even then it's optional. Then it will just take the one with the least arguments, but that might not be always what you want. But for a method, you of course need to tell it which method it is. So in this case, I'm injecting the game web information in the unit layer, and I set my properties, and I'm done. This is basically just a constructor, and it's going to be run before awake is being called. At least that's what the dependency injection framework claims. I haven't tested that yet, but so far it seems to work fine, so I'm guessing that's what it does. And should actually log that out and figure that and see whether that's actually what's happening. In here, I don't need anything, but in the unit layer, I think I need something. And as you can see, here I'm injecting a unit factory. That was another thing. I needed to create units in here, and the unit layer was doing that on its own, and that's fine. But in testing, oh my God, now this is creating actual units, and then the units have dependencies on their own, and that's all falling apart in unit testing. So in this case, I'm just doing a unit factory. So where's this thing coming from? Let's look at the implementation. That gets injected the prefab and the parent where this is supposed to end up. And as a factory base, it also receives the inject container and the logger. And then I can just go ahead and create units. I instantiate this stuff from a prefab. The Zenject container has a lot of methods that are Unity specific, so you can instantiate prefabs and all that kind of good stuff. I give it the prefab that it's supposed to instantiate the new object from. I give it the position where it's supposed to end up, a rotation and a parent, and this is basically the code that used to be in the unit layer. Now I can set all that up, give it back to the unit layer, and the unit layer doesn't need to know anything about it. If you look at create unit now, where is it? Down here. I just get the actual position from the cell position, give that to the factory, add it to my own lookup stuff, and I'm done. I don't need to worry anything about how this gets created. I just give it the type that it should create, the position, and I'm done. And that is way better. Another thing that I had to think about is cross-cutting concerns. As I mentioned, the message broker and the logger, all that stuff that in unit testing is really going on my nerves. How do I get that out of here? I also don't want to make this a virtual function and constantly pass the logger and the message broker to my base class. That's hugely annoying. So I did that a different way. I put that actually in the base class by injecting that here as either a field injection or a property injection. I can do that however I like. In this case, I do it with property injection. So this gets ejected in the base class all the time. And my derived classes don't have to know about that. Same with the factory. The factory obviously needs the container, but the container just gets injected via property injection into the base class together with the logger, so I don't need to worry about that. So it's not like whenever I change my base class and I want to add another cross-cutting concern, I need to change all the methods on all the containers. That's just exactly what I'm trying to avoid. What would that help me if I avoid dragging that left and right in the Unity inspector, and then I need to do in the Unity editor inspector, and then I end up doing the same in code, and I constantly have to jump around and inject stuff here, left, right, and center. No. Here I just add the inject on the property in the base class, and then I can forget about it. Don't need to worry about doing that in all the derived classes. The derived classes just ask for the stuff that they need. And here, as you can see, the prefab gets injected with an ID, because obviously it's not the only game object that I probably expose. And I created a nice little static class here. Oh, that needs actually a documentation header, I just see. I should put that in here. Add that. So here I just give my prefab some names. So prefab IDs, unit, that's my name. And let me look at the actual installers. I have, of course, this is all getting too big. Shouldn't have this all open. There we go. Here's the game installer. In here, I publish the message broker from an instance. UniRx has already a singleton instance to a standard message broker. In the unit test, I'm instantiating a new one. And the logger I can create from a method, since here I need to pass the object that it gets injected into. So we can have the appropriate ping functionality in the log. So I'm giving the object instance unless that doesn't exist, so it might be a static injection or whatever. In that case, I'm just getting the object name or the actual type of the object full name. So that is my nlog manager that I also now encapsulate into my nlog logger, which derives from iLogger, which is my interface, not the Unity interface. As you can see in diagnostics, I actually have a couple of other ones. I have a null logger, which basically doesn't do anything. I can use that for unit testing, for example. Or I can just replace it with the Unity console logger, which only writes to the console. Or I can have in-game the actual nlog implementation, which goes to files and all kinds of targets that I can set up in the Unity editor. And in my base class, I also set by default the component thing to my Unity logger, and the asset base I set to the null logger. That has certain reasons, because I'm not always going to inject into every asset. Some stuff just lies around like brushes and stuff, and I don't want them to log all the time. I just want those to really log if I actually am using them for something fancy. And if I'm using them for something fancy, they will get injected. So this instance will get overridden by the dependency injection framework. Components will probably always be used for something fancy, because otherwise why would I have written them? So they by standard do the Unity console logger for the edit mode stuff, because if I'm in edit mode, I don't want that to end up in a file log anyway. I just want to see that in the editor. But as soon as I go into play mode, this will get overridden by the actual runtime logger, and I'm good to go. So this is working perfectly. Let me look at my test implementations, because that's actually what all this is about, to make that also nice. And if I go in here, I have my Unity text fixture, which derives from Zenject unit test fixture, which doesn't actually do a whole lot. It just offers you the container. That's all that does. So why not use that? Then I don't have to write that for my own. And I'm also injecting a logger and a message broker in here, and I'm defining those on my own. For the logger, I'm just using a substitute from NSubstitute. That's a mocking framework. And for the message broker, I'm just creating my own new instance, so that doesn't interfere with any edit code running somewhere. So I install those bindings and I'm good. Here I can override that virtual method, so the test can add its own bindings. I have my receive and my publish now working on the unit test message broker, so I can still publish and receive messages in the test to see whether my tested component has actually sent the proper events, and I'm good to go. And if I need the logger substitute for something, then I can even check whether the appropriate calls have been made to it. Obviously, I have certain things for the components itself and for the assets. In here, we just have a binding to the actual component, which will create it on a new game object as a new component. And then I inject that into myself, so I have the tested component. And then, of course, I activate it and enable it in case this is still reflection magic, where I call the onEnable. I do that because in the edit mode tests, I still sometimes will need to call onEnable because they need to subscribe to the events to actually be, so I can test whether they're actually publishing them. And since the edit mode test will not enable the object because it's not actually being run, I do that in there. I find it silly to make a play mode test out of it just to be able to call onEnable and onDisable. I can do that on my own. Then I can still have them in edit mode test, and that just runs faster. And then let's just quickly jump into one of my tests, just to see what that looks like in practice. Let me see, which one will I pick? I should go into some of the game map information tests. Here I do some setup stuff. I check whether certain events have been received. I set up certain positions on the map and stuff like that. And all the way on the bottom here, I set up my bindings. Of course, I want a new map. I set some stuff on it, and then I bind that instance in the container. Since that instance already exists, nothing will get injected into it, but the game map itself also has dependencies, so I queue it for injection itself. I bind the camera to a completely new game object. I bind the event system to a completely new game object. So those are basically stubs. And of course, I bind my test terrain type to something, because that will actually end up to be the ones that are used for randomization. Probably set that up in here somewhere also. Where do I have it? Here. Test terrain type. I just create a new instance and we're done. Not actually sure I need this. Oh no, I do. I set up some stuff on the map with that. And then in the tests, I can go ahead. I can just say, oh, clear when the map is not null, will not throw. So I can check whether it throws. If the map is valid and I call clear, then the terrain and the unit positions should be empty. And here I'm basically using another library, which should show up here somewhere. Oh no, it's actually just the DLL. So let me show you the references to it. There we go. Assemblies. Shouldly, I highly recommend that. That's a thing that makes your assertions into something that is actually human readable. You can just have like this. Instead of assert is not count equal null or bullshit like that, I can just say game map all terrain acceptance should be empty, or should not throw, or should be true, stuff like that. And that's just absolutely amazing that I can write it like that. I really like that API and I highly recommend it. That's not NSubstitute, that's that shouldly thing. The NSubstitute comes in here when, let me actually see, where do I actually have something like that? Let me actually go into the unit layer. I think I have an example for that in there. Gameplay unit layer. There we go. Here, Here I can say, okay, I created tile map. I publish the map changed event. I ask for all the units. That count should be the same as the unit positions that are defined on the map. And now I can say for all the unit positions, the factory should have been called to create a unit for that position. So the unit factory should have received exactly one call to create with the position and the tile that is supposed to be where the position is supposed to be, where the unit is supposed to be created at. So the tile center position. If I actually should probably extract these two into temporary variables that might make this a little bit more readable. But as you can see, ReSharper, or in this case, writer, is actually adding some stuff. So this is basically just the unit type and the position. So the create method on the factory should have been called exactly once with these arguments for each unit position. And that's my test. And I think that is very readable. This is my fault that this is not super readable, because this should be these should be temporary variables with a little bit more readable names instead of just putting the calls in here. But aside from that, this would basically read factory received one call to create with the type and the position for each of the unit positions. I think that is super readable. And I just install my bindings down here again, the game map information, the unit factory, and the logger, and I'm good. In this case, I'm using the Unity console logger. I'm actually not sure why I'm doing that. This could just be a substitute, I think, but whatever. Maybe I wanted to actually see then the log and for once. And in here, I inject that into my own test, and I have those available to check calls on them. So I think this is way better. I can now just inject everything anywhere I need. I don't need to worry where it comes from. It will just be there. And whenever I create something new, I either declare it in one of my installers. Oh, I haven't actually shown you the grid installer yet. Or I use these Zenject or that is Zenject binding components in the actual scene. Grid installer is not much more difficult. It just has something in here where I can say all the terrain types that exist. I can define the unit prefab here as a serialized field, and then it's just going to go and install those as binding. It's going through every terrain type and publish that as an instance. It's going to bind my unit prefab under the appropriate ID, and it's going to create a unit factory from code and makes that available. And I'm just in here, that's just Odin validation stuff. So I can check whether this is actually the correct prefab. So it actually has an iUnit component. And then let me quickly go back to the editor. And here you can see what that looks like. Here is my grid installer. And here I defined all my unit types and the unit prefab. So now I don't put that where it's actually needed. I put it just a little bit more global so everybody has access to it. So anybody that needs all the available terrain types can just import them now. Everybody that needs the unit prefab can just import it now. I mean, I might be able to make the prefabs a scriptable object and put that somewhere in the assets and give the unit prefab to that. Those are design decisions that I need to think about later, who actually needs the unit prefab. For now, I have it here. I could just put that on a scriptable object, make the factory not a normal class, but a scriptable object down here, export that in here, and make the factory available that way. There's different ways you can do things, and I think this is very, very flexible because the UI is great. I don't have anything in terms of dependencies on my gameplay UI. I just put my Zenject binding components on anything that I need. And in my code, if I go into the actual UI, here I have my create method, and it's just asking for the right button, the right texts, and I'm just getting that in here. I have my properties, and then I can just work. And the major advantage of that for UI is something you constantly change. You move that around, you reorient it. Okay, yeah, that button should probably be over here, and I'm gonna pack that into another canvas. and I'm going to rename it and everything. And sometimes these links might break, or you're going to create a new button. I mean, if you move it around, the meta files will probably make sure that that still works out. But let's say I'm creating a new button, like, I don't like that one, I'm throwing that out. Or the canvas group, like the pop-up. Maybe I want to do the pop-up some different way. I'm going to put that somewhere completely different. I'm making a canvas group in a completely different place with completely different setup. Now I have to drag that in the appropriate place and figure out, oh my God, how many components were dependent on that and who needs that? I don't need to do anything here. I just need to make sure I have that binding component on it that gives it the right identifier, and then I don't need to worry who needs it. It will end up in the right place. I don't need to drag it everywhere and figure that out and do all the fancy stuff here. Oh yeah, now I need to lock this so I can have this window open so I can appropriately drop that from this in here, and oh, now I clicked on it, now the inspector closed up again, all that fancy stuff. I mean, that's not a big deal, but it's that little annoying stuff that costs you time when you need to drag stuff all over the place. Maybe open the second inspector so you can drag stuff left and right appropriately. Not stuff I want to do. I just want to put the binding component in here, and it's all going to work. And I don't need to worry about who needs it or how they get it. It's available. Whoever needs it gets it. And that's easy. And that is saving me a lot of time. It took me 12 hours to actually put that in there. Most of that time went into refactoring all the code and in the tests. Not actually the gameplay code, but the actual testing code. But that also made my tests a lot more readable. I also put this in here, changed all my asserts, also changed this. That was also something that I made a design decision. Previously, I had a major documentation header over here, and every assert had its own message. And then I thought, Jesus, do you actually need that? You have a method name that is supposed to tell what the test is doing. Then you have a documentation header that tells me again what the test is doing. And then in the assert, I have a string that tells me again what it failed to do. So that was kind of triple redundance, and I thought, come on. Or actually double redundance, I should say. The original is not the redundancy. But yeah, I thought, okay, I don't need double redundance. That's just ridiculous. I don't even need single redundance. I just want the original thing. So I looked up what are popular naming schemes. I've seen several in the past. I decided for this one, the method name, the condition, and what it's supposed to do. So remove terrain type, if terrain has actually been removed by it, raises this event. If nothing was erased, it doesn't make that event. If the map is null and I call the method, it should not throw an exception. It should simply do nothing, and all that kind of stuff. And then the shouldly instead of the asserts, and that makes it all way more readable and all nice and good. So I'm very happy with this, the way it is right now, that I didn't make a lot of advances in the actual game, but I got this to a state where I can actually now work again and where I can do proper, at least partly test-driven development and write my tests in a way that I can actually work with it and not have basically the tests take forever because the design is not set up so it's easily testable. Now I can easily test stuff, especially since I now have factories and dependency injection. Now I don't need to worry about where my dependencies come from, write fancy reflection code to get that in there. But I can just keep on going. And you see I have nice small tests that are easily readable for the most part. Writing readable tests is hard to begin with. And if your framework makes it even harder, that's not nice. And I didn't like that I spent most of my time writing the tests and not the actual game. That's often the case anyway, but yeah, I like to limit that to a minimum so I can actually focus on this stuff. So that's been it for today, I would say. I hope you liked this introduction to my approach to dependency injection and to what my reasons were for using it. And next time I will actually change something else, which I didn't want to talk too much about this time. But I'm going to show you anyway before I let you go. Obviously, I still have the in-editor code, among other things for the map creation. Like if I go here, I of course still have that stuff in here, the randomized terrain, and I have the palette, of course, if I paint something and I just add stuff in here, paint new units or new terrain types, the appropriate layers need to update, and they need to listen to the events. For that, they need the message broker and all that kind of fancy stuff. So how did I actually do that? Well, let me go back to the code, and I'm going to show you how I did that. Not in a very nice way. So first of all, I set up my own static editor context, and I gave it a dependency injector, and then I did some fancy logic in here. Whenever this gets set up, I'd go in here and look for my grid installer somewhere. If that doesn't exist, I'm not in the right scene, so I'm not going to do anything. If it does exist, I'm going to grab the unit prefab from it and store that. Then I'm hooking up to the project changed and play mode changed events. And then I'm checking, okay, are we actually switching currently into the play mode? Because then the edit mode changed still flies, but the edit mode entered event still flies, but that is happening right before the actual play mode is being entered. So apparently in play mode, you are in edit mode and play mode at the same time, which is a little weird how Unity defines that, but whatever. But in any case, you basically get 4 events here: enter edit mode, exit edit mode, enter play mode, exit play mode. And apparently if you go into play mode, you get an entered edit mode and entered play mode right one after the other. So you get an exit edit mode right before you enter play mode, but then you get an entered edit mode again. So if you're entering into play mode, you enter a new edit mode and the play mode. And when you exit play mode, you go only into a new edit mode, so you're kind of always in edit mode. You're just in a different edit mode when you're in play mode. Yeah, you can figure that out on your own time. But anyway, this is how you check for that. And you make sure that you are only in edit mode. And if I'm going into edit mode, I'm saying, okay, then I create a new dependency injection container because I want that to be set up every time I get into a new edit mode. I don't want that to still exist in play mode. I get all types. No, this is not it. This is getting all terrain types. That's not what I'm actually doing. I'm setting up my bindings. As you can see, I need the event system, camera, blah, blah, blah. All this exists because I checked previously whether I'm in the right scene. Then I'm going to get all injectables. I inject into them, and I'm telling them that we're currently in edit mode. And on exit mode, I'm telling them that we're leaving edit mode, and I'm throwing away the container. So this doesn't interfere with play mode. In the injectables, I'm finding all objects that are not a prefab, that have a certain in edit mode inject interface, and those are the ones that I inject into. And this edit mode inject interface is something that I defined, and that, for example, the grid information system defines. So where is that actually at? It's down here on enter edit mode and under exit mode. And in edit mode, I just want to refresh. And for example, the unit layer, if that goes into that, it wants to subscribe to certain events. So it listens to the map updates. And on exit mode, it throws away those subscriptions, just like it does in on enable and disable in play mode. So that is something that it's working. I actually looked through Zenject, the forums, and people are actually discussing, okay, how can I do dependency injection in edit mode? And this is a problem that's being discussed there. Zenject kind of decided not to offer a solution for that because that's not what the framework is for. But here I showed you this is actually something that you can do. I could probably also create a different installer static class for every scene and go in my editor context here and check, okay, what scene are we at? Probably with something a little bit more fancy than this. Just checking whether a grid installer exists and then saying, okay, if a grid installer exists, then I need to be in the right scene. That's probably not going to scale very well, but you could check for the right scene and then in here set the appropriate bindings for that scene. And yeah, this injectable thing it looks big, like it goes through all the objects, but actually it just takes a couple of milliseconds for this to execute, so it's not that bad. Probably not something you want to do in play mode, but for edit mode, it seems to be performant enough. So this actually works, but I'm not 100% happy with this solution. So the next step will be, again, all this edit mode stuff kind of has no place in my play mode components. So I'm going to strip that out, put it into an appropriate inspector, into a custom inspector class, into appropriate map editor inspector class. And that will also give me a chance to actually look at UI elements, because for editor extension, that is, of course, already released and fully capable, fully functional. So I'm going to use that for that. Build myself a nice little map editor inspector for the grid component, or rather my map information system component that rests on the same game object as the grid. And that will be for next time. And then I hope I can get rid of all this crap, which was a nice exercise on trying to figure out how I could get something like this to work. I just think it's probably not the best solution for what I'm actually trying to achieve here. But it's nice to know that this can actually be done. So in case I'm probably going to put this eventually on some place on GitHub, just so someone that actually needs something like this can take a look at it, and maybe you have a custom system where this actually makes sense. Then you can take advantage of all this fancy stuff. Unity offers the appropriate events and callbacks, so you can set up something like this. Probably make this a little bit more complicated, so you can actually refactor those bindings out, put them in the appropriate installers. So you have an edit mode installer for all your scenes, and this thing just hooks up. It already gets notified if the project changes or if the hierarchy changes. So you get notified. You can just figure out, okay, I probably loaded something new. I need to check the scene again, throw my container away, install the new container for this scene, and inject everything. Certainly can be done. You can also inject into brushes that fly around and all kinds of objects that are not even in the scene, but are scriptable objects that are sitting somewhere that need certain stuff injected, like the logger, for example. You can absolutely do that with this. And I might even keep this to inject the logger into everything that is flying around somewhere, because I don't know how else to inject into a brush, for example, like the standard default instance of the brush in the tile palette window. Like, how would I inject into that? By the way, edit windows also derive from object. So you can actually inject into editor windows like this, which is probably something interesting for you. Like, you just go through every editor window, change this from object into just editor window like this. As you can see, that works. That is an appropriate call for this. And then you check for your specific type. I mean, you can even, if you just want one specific window, you can even put that in here. And then you maybe check whether that type also has this interface. So you only inject into those that actually have that. And you're good to go. So that works also. Not sure whether anybody's going to need that, but I thought I'd just tell you that I found a solution for that. Not sure I'm going to keep it, but maybe for editor windows and for brushes, but probably not for the stuff I'm currently using it for. But it is certainly something to do. That's also why this thing doesn't have a documentation header yet, because I'm probably going to throw it away. But yeah, just showing you that that exists and you can do it. But nice little inspector for this is probably what I actually want. So whenever I'm on this, I want this to be a proper map editor where I have all the functionality to edit the map in here and not have to use the tile map window, which is not really appropriate for my use case anyway. So that is going to be it for today. Hope you're looking forward to the next one, where I can probably get you an introduction to my first experiments with UI elements. So until then, keep your heads up, folks, and I'll see you on the next one. And as always, in these times, stay healthy out there.